All right, let's jump into another deep dive. Today, we're going to explore escape velocity.
Oh, cool.
We've got a web page from Open Educational Resources. It's open source physics at Singapore. And they've got like this really cool interactive simulation that helps us wrap our heads around this whole idea of escape velocity.
Yeah, these interactive simulations are fantastic. They really help make these complex physics concepts way more accessible, for anyone who might not be like a physics whiz.
Yeah, and this web page, it's got the simulation model.
Okay.
And it's got like the longest title.
Oh, really?
Yeah, it's like 7.3.8.6.3 Earth-Moon escape velocity, field strength, one-dimension JavaScript, HTML5 applet simulation model.
Wow, they really went all out with that title.
I know, right? What's with all the numbers?
Well, it's actually pretty interesting.
Wow.
Think of it like a super specific roadmap. It tells you exactly where the simulation fits in their whole like organization of the website. Basically what it means is it's a simplified model, right? Looking at how the Earth and the Moon's gravity, affects something traveling between them.
Okay.
In a straight line. So just in one dimension, actually this kind of shows how carefully they've structured all their content. Everything's got its place.
It's very organized.
Yeah, very organized.
So it's kind of like a zoomed-in view
Yeah.
of this, interaction between the Earth and the Moon.
Exactly, yeah.
But, okay, hold on. Let's rewind a bit. Can you explain escape velocity?
Sure.
Like, in simple terms for those of us who, might not be totally familiar with it.
Absolutely. So escape velocity is basically the minimum speed, right?
Yeah. That
something needs to escape the gravitational pull of a planet or a star or, anything in space, really. Like, imagine you throw a ball upwards. It falls back down, right, because of Earth's gravity.
Yeah, that sounds familiar. Happens all the time.
Right. But imagine if you could throw that ball with enough speed at the beginning. That initial speed is the escape velocity. It would overcome Earth's gravity and just keep going, like forever. And eventually, it would just leave Earth's gravitational influence behind.
So that's basically like how we launch rockets into space.
Precisely. Escape velocity it's the key. And it even applies to like crazy objects like black holes.
Oh, wow.
A black hole has something called an event horizon.
Right.
That's the point where the escape velocity is so high that even light can't get out.
Oh, wow. Yeah, that's mind-blowing.
Yeah.
So is there like one escape velocity, like a speed limit?
Well, that's where it gets kind of cool. It's not one fixed number.
Okay.
Escape velocity depends on two main things: the mass of the planet or the star, whatever you're trying to escape from, and your distance from its center.
Okay, so like I'm guessing a huge planet like Jupiter would have a way higher escape velocity than like a small asteroid.
You got it. The bigger the object, the stronger the gravity.
Right.
So you need more speed to escape. And as you move farther away, the gravity gets weaker. So the escape velocity goes down.
So the distance matters too.
Absolutely.
Yeah.
It's all about that interplay, right?
Yep.
Between mass and distance. And this simulation, it focuses on the Earth and Moon system specifically. And, it's a one-dimension model, which means it's simplified. It focuses on, just a straight line between the Earth and the Moon, which helps us get the core idea without, getting too bogged down in all the extra complexity.
That makes sense. And what's really cool is that anyone can use this simulation. It's free. It's open source.
Yeah, that's the best part. And it's a perfect example of this whole movement of open educational resources.
Right.
OERs and this website, Open Source Physics at Singapore, they're like a prime example of that. Basically, OERs are like these educational materials, right? That are they're free for anyone to use. You can adapt them, you can share them. It's really amazing.
So it's kind of like making education like accessible to everyone.
Exactly. It doesn't matter where you are, what your background is. Everyone can learn. And that's especially important in a field like physics, right?
Yeah, absolutely.
Because physics is always changing.
It's always evolving.
Exactly. There are new discoveries all the time. So these OERs, they let educators and students, they let them keep up with all the latest stuff. And they encourage people to work together, to collaborate. And it means that these materials are always being updated and improved.
So for our listeners, like OERs could really change things for you. Imagine you have access to to this whole library of resources that are constantly updated, whether you're trying to learn something new or teach a class, or even just if you're curious about something. It's a pretty amazing thing when you think about it.
It is.
But let's zoom back in on this specific web page.
Okay.
What else is interesting about it? What stands out to you?
Well, one thing I noticed right away is how they use these things called breadcrumbs, like that roadmap we talked about earlier.
Right.
It shows how organized they are, how committed they are to making it easy to find information.
And there's this, there's an embed code snippet.
Oh, yeah.
So that means anyone can share the simulation.
Yeah, absolutely. Yeah. Anyone can share it on their website, their blog, whatever.
Wow.
And that's typical of these open source projects. They want people to share knowledge.
Yeah.
They want people to build on what they've created. Collaboration is so important.
Yeah. And I also saw this translation section.
Oh, interesting.
So could that mean that the simulation is available in other languages?
Yeah, I think it probably does. It seems like they really want to make this resource accessible to everyone around the world, which is fantastic.
Yeah.
Now, did you notice the resources section? It links to a GeoGebra model created by Tenzing Huang.
Oh yeah, I did see that. What's GeoGebra? Is it another way to like visualize escape velocity?
You could say that.
Okay.
GeoGebra it's this platform where you can create interactive simulations, for math and science. So it's possible that this model, this GeoGebra model, it shows escape velocity from a different angle, right? Or maybe it focuses on specific details that the simulation doesn't. Or maybe it's even a totally different simulation that explores a related concept.
So cool. It's like having different tools to explore the same thing. Each one gives you a different perspective.
Exactly. And it helps you understand things better, more completely.
Yeah, absolutely. But before we jump into the simulation itself, let's just take a moment to appreciate the people who created all this.
Oh, for sure.
They put so much work into making these complex ideas accessible to everyone.
Yeah, they really care about making education open and engaging.
Absolutely. This open source physics at Singapore platform is really amazing. But hold on to that thought, because we're going to dive into the simulation itself when we come back.
Sounds good.
Welcome back. Now let's get into the real heart of this web page.
Okay.
The simulation. What makes this one so engaging?
Well, the really cool thing about it is that it's interactive.
Okay.
It's not just a video. You can actually experiment with it.
Oh, wow.
You can change different things and see how it affects the outcome.
So it's hands-on.
Yeah, exactly.
So I'm guessing you can change things like the mass of the Earth and the Moon, or even how far apart they are.
You got it. You can adjust those parameters, and then you see how the escape velocity changes. So if you make the Earth more massive, the escape velocity would probably go up because the gravity's stronger, right?
Right. It's like having a physics lab.
Yeah.
Right on your computer. It's way more exciting than just reading about it in a textbook.
Oh, yeah, definitely. It's way more hands-on, and that helps you really understand the physics behind it.
Absolutely. So obviously we can't interact with the simulation right now because this is a podcast.
Right.
But can you kind of paint a picture for our listeners?
Sure.
What would they see if they opened up this simulation?
Okay, so imagine, a simplified view of the Earth and the Moon. Maybe there's a dot that represents a spacecraft or something, positioned somewhere between them. And then there would be some controls, sliders maybe, where you can change the mass, the distance, all that stuff.
So you adjust the slider and you see the escape velocity change.
Exactly. It would update in real time. And the simulation might even show you the path of the object, does it escape or does it fall back towards the Earth or the Moon?
I'm picturing a little rocket icon, trying to blast off into space. If you get the settings right, it goes. If not, it crashes.
Yeah. Perfect analogy. And the cool thing is you can just keep experimenting. Try different scenarios, see what happens. It's a really powerful way to get a feel for how these forces work.
Yeah, and it shows how creative the creators were.
Yeah.
And how much they cared about making physics fun and accessible.
The fact that they put all this effort into this and then made it free for everyone to use, it's really inspiring.
Absolutely. So we talked about the resources section earlier,
right?
And that link to the GeoGebra model by Tencent Quang.
Hmm.
Let's talk a little bit more about that. So I did a little research, and it turns out GeoGebra it's this platform where you can create interactive math and science simulations.
Yeah, it's really popular. A lot of teachers use it.
Yeah.
To help students visualize things, to help them explore like geometric relationships, and you can create these models that change as you interact with them.
That's so cool.
Yeah.
So how could this specific model help us understand escape velocity? Like, could it give us a new way of looking at it?
Yeah, it's definitely possible. It might focus on different aspects or present it in a different way, than the JavaScript simulation, or it could even be a totally different simulation.
Okay.
Exploring some other physics concept that's related.
So it's like having different lenses to look at the same thing.
Exactly.
Each resource, whether it's the Java simulation or the GeoGebra model, it gives you another piece of the puzzle, and it helps you understand the whole picture better.
And the fact that they're linked together, it just shows how connected all these online learning resources are.
Yeah.
It's like this huge web of knowledge out there.
It's amazing.
And you can just follow the threads and explore.
It's like a choose your own adventure, but for physics.
Yeah, I love that. It really shows how creative and resourceful people are when it comes to learning and teaching.
This deep dive has been so eye-opening.
Yeah, me too.
I've always been interested in space and the physics of it all. But exploring things like this simulation, this open source physics platform, it's just made me even more curious.
I know what you mean. It's amazing to see how technology and these open educational resources are changing the way we learn.
Absolutely.
And they're helping us understand these really complex ideas. And who knows what else is out there, just waiting to be discovered.
That's the best part about these deep dives. We find these hidden gems, these valuable resources. But, let's think about how this relates to our listeners. We've talked about escape velocity, we've talked about simulations, OERs, but what does it all mean for your everyday life?
That's a great question. When you think about it, understanding escape velocity, it's not just about space travel. It's about understanding the fundamental forces that govern the universe.
Yeah.
Like how gravity and motion work together to shape everything around us.
And even if you're not a physicist or an astronaut,
right?
These ideas they're all around us.
They are.
Think about all the technology that relies on our understanding of gravity.
Yeah.
Like satellites for communication, GPS systems. We use them every day.
Exactly. And even if you don't work directly with that stuff, appreciating the science behind it, it just helps you understand the world better.
Yeah, absolutely. And that's where things like this simulation come in. These open educational resources, they give you the tools to explore and learn about whatever you're interested in.
Whether you're a student or a teacher or just, someone who loves to learn new things.
Yeah.
These resources are out there just waiting for you. And they're always changing. There's always something new to discover.
So dive in, explore, experiment. Let your curiosity lead the way.
You never know what you might find.
Exactly. So we started by, really breaking down that whole idea of escape velocity, that speed you need to actually escape the gravity of a planet.
Yeah, it's that crucial point where you finally break free. And we talked about how escape velocity isn't just something, theoretical. It's what makes space travel possible.
Exactly. It let us launch rockets, explore the cosmos, and we saw how this whole complex idea, it's actually brought to life in this amazing JavaScript simulation on the open source physics at Singapore website.
Yeah.
And that tool, it lets you can play with all these variables, and see how it affects the escape velocity you need. It's it makes physics so much more hands-on,
Yeah, definitely. It's way more engaging than just reading about it. And we also talked about the bigger impact of open educational resources, like all those materials that are freely available.
Yeah.
That are making education accessible to everyone, no matter who you are or where you are.
Yeah, it's like opening up this whole universe of learning.
It is.
And remember that GeoGebra model we found.
Oh, yeah.
That link, it just shows how connected everything is.
Yeah.
There's this huge network of resources out there, and they're all linked together. It's incredible.
It's a whole world waiting to be explored.
Yeah.
You can just follow your interests, hop from one resource to another, create your own learning path.
It's like a choose your own adventure, but for for learning.
Exactly. I love that. But before we wrap things up, I want to leave you with a question.
Okay.
We've talked about, how escape velocity works, but what about the future of space exploration? What kind of challenges and possibilities does escape velocity, present as we try to reach other planets or even go beyond our solar system?
That's a really great question. Like to get to those faraway places, we'll need to reach some incredible speeds.
Yeah.
And that's going to push the limits of everything we know and all the technology we have.
It is. It's going to require some serious innovation to break free from Earth's gravity and journey out into the vast unknown. It's a pretty exciting thought.
It is. And maybe this deep dive has sparked a different question for you.
Hmm.
Like what other physics concepts could we learn about through these interactive simulations?
Hmm.
What other areas of knowledge could we explore with these new tools? The possibilities are pretty endless.
They are. And that's what makes it so exciting. Learning, it's a journey. It never really ends. And it's driven by our curiosity, by our desire to understand the world around us.
And these resources that we've been talking about, they're like the stepping stones on that journey.
Hmm. They help us see things in new ways. They spark our imagination. They fuel our passion for learning. And I think it's so important to never let that passion fade away.
Yeah, I completely agree. This deep dive has been truly amazing. We've gone from the basic ideas of escape velocity to the practical uses of open educational resources.
Hmm.
And I hope it's inspired you to keep exploring, keep asking questions, keep learning.
Me too.
So until next time, keep those brains buzzing.